my dear children. Welcome back to the physics class. Today we are going to learn about the next simple machine, that is pulley. This is a pulley, and a pulley consists of mainly two parts. An axle which passes through the center of a wheel. The wheel is not like a normal wheel of a bicycle. It has grooves. And when we use this pulley, a rope passes through the grooves and the effort is applied at one end of the rope. A single pulley can be used in two ways, fixed pulley and movable pulley. Let's go in detail about fixed pulley. A pulley which has its axis of rotation stationary in position is called fixed pulley. A single fixed pulley has its axle fixed on the support and an inextensible strong thread of negligible mass passes around the grooved rim of the pulley. One end of the rope is connected to the load while effort is applied at the other end of the rope. Here, load gives a downward force on the rope and rope will give an equal and opposite force called tension. On pulling the string by applying an effort on the other end, load moves up. This is a fixed pulley. Here, the load is hanged at one end of the rope and effort is given at the other end. The load exerts a force equal to its weight downwards and the rope gives an equal and opposite tension upwards. This tension acts on the side of this wheel. The effort given on this side of the rope produces a tension upward which acts on the other side of the pulley. So here in this case, the load produces a clockwise moment and the effort produces an anti-clockwise moment. The load tends this wheel to rotate in clockwise direction and effort tends this wheel to rotate in anti-clockwise direction. So we can apply the principle of moments here. According to principle of moments, in equilibrium, that means when this wheel is in a steady state and when it is not rotating, sum of the clockwise moment is equal to sum of the anti-clockwise moment. The clockwise moment is due to the load. So, clockwise moment is equal to load into distance from load to the pivoted point. Here, the load exerts a force here in this pulley and the fixed point is this axle and the distance from axle to this rim is equal to radius of this wheel. Isn't it? The same way, effort exert downwards and which produces an anti-clockwise moment, and this anti-clockwise moment is equal to effort into, because effort acts here, and effort into distance from effort point to the axle, which is also equal to the radius of the wheel. Since both the distances are same, we can cancel. So we can write load into radius equal to effort into radius. When you cancel this radius, we can write load is equal to effort. Here, load is equal to the tension exerted by the rope, because the tension acts as the load on the wheel. So load is equal to tension of the rope. And to balance this pulley, we have to give the same force as effort. That means effort is also equal to tension of the rope on the other side. So we can write load is equal to T and effort is equal to T, because load is the tension of the rope in the side and effort is the tension of the rope in the side. Now, the mechanical advantage is equal to load by effort, which is equal to T by T and is equal to 1. So here the mechanical advantage is equal to 1 since load is equal to effort. And this pulley is used to change the direction since mechanical advantage is equal to 1. There is no gain in speed or gain in force in this case. Now we can think about the velocity ratio. Suppose this rope is having 5 meter length. When you move this effort 1 meter, that means when you move this rope downward by 1 meter, the load will move 1 meter above. That means if displacement of the load is 1 meter, the displacement of effort will also be equal to 1 meter. Since displacement of effort is equal to displacement of load, we can write velocity ratio. What is velocity ratio? It is displacement of effort by displacement of load, which is equal to 1. So here velocity ratio also equal to 1. So we are considering the ideal case. In ideal case, mechanical advantage is equal to velocity ratio. So if mechanical advantage is equal to 1, velocity ratio must be equal to 1. So this is about the single fixed pulley. And this is the ideal condition of single fixed pulley. But in real case, when this rope rotates, due to the friction between the rim and the rope, some energy will loses, and hence this effort needed to lift this load will be more than that of the original load, or effort will be more than that of the load, and hence the mechanical advantage reduces. But velocity ratio remains same because it is related to the movement of load and effort. Now we can move to the next section, that is single movable pulley. A single movable pulley is suspended by passing an inextensible string of negligible mass around the grooved rim. The load to be raised is suspended from the axle. One end of the string is tied to the hook at a rigid support, and the effort E is applied at its free end. The tension T acts on the string on both sides of the pulley as shown. This is a single movable pulley. This pulley is free to move through this rope, and the load is hanged on the axle of this pulley. Now let's think about this load. This load is given tension on both sides of this rope. That is, a tension T acts on both sides of the rope, and sum of these tensions, that is 2T, is equal to load. So load is equal to sum of the tension on the rope. It is just like if a load is shared by two persons, one person has to give an effort equal to half of the load. Here the load is balanced due to the reaction force on both sides of the rope. The reaction force is called tension. So this tension balances the load. That means sum of this tension is equal to load. Effort is given here, and that means the effort has to balance the tension of this free end. The tension of this side will be balanced by the rigid support. We are supporting this rope on a rigid frame, so that this rigid frame give a reaction force to balance this tension. And the effort we have given must be equal to the tension of this free end. So effort is equal to T. Now what about the mechanical advantage? Mechanical advantage is load by effort. Here we have seen load is equal to tension on two sides, that is 2T, and effort is equal to tension on the free end, that is T, which is equal to 2. Okay. So here the mechanical advantage is equal to 2. Since this mechanical advantage is equal to 2, this pulley is used as a force multiplier, or it multiplies the effort 2 times. Now let's look about the velocity ratio. Suppose this string has a total length of 10 meter. That means this side of the string has 5 meter and this side of the string is 5 meter. Then in total it comes 10 meter. Okay. Now if an effort is applied to lift this rope in upward direction by 1 meter, that means the total length of the rope is reduced by 9 meter instead of 10 meter now. So the length of the rope after this effort point is only 9 meter. 9 meter means 4.5 meter on this side and 4.5 meter on this side. Is it? Because the total length was 5 meter. Now it is reduced by 9 meter. That means 9 meter is shared by the two sides, means it is 4.5 and 4.5. Now let's look. The displacement traveled by the effort. That is, effort point is from here, it is moved by 1 meter. So displacement traveled by the effort is 1 meter. And displacement traveled by the load, it was 5 meter below. Now it is lifted by 0.5 meter. Now the difference is only 0.5 meter, 4.5. So displacement traveled by the load is 0.5 meter. Isn't it? Hence the velocity ratio is equal to 1 by 0.5. That is 10 by 5 is equal to 2. So here the velocity ratio also equal to 2. Hence this movable pulley is used as a force multiplier. In ideal case, since there is no loss of energy, mechanical advantage equal to 2 and velocity ratio is equal to 2 and the efficiency will be 100%. But in real case, when we lift this load, since this load is hanged on the movable pulley, we have to give an effort equal to load plus weight of the movable pulley. Hence, the weight of the movable pulley is added with the load. Hence, we should give more effort and also the friction of the rope acts. Hence, in actual case, we need to apply more effort and so mechanical advantage reduces and the efficiency also reduces from 100%. But the velocity ratio, since it is related with the movement of load and effort, it remains same. With a single pulley, the effort is to be applied in upward direction. However, it is inconvenient to apply an effort in upward direction. Therefore, a movable pulley is used along with a fixed pulley to change the direction of effort. The load is attached to the axle of the movable pulley and effort is applied in downward direction at the free end of the string passed over the fixed pulley. Here also only two strands are supporting the movable block, hence the reaction force of these two strands balances the load, hence load is equal to 2T, and effort is balanced by the reaction force of the free end of the rope, hence effort is equal to T. Hence mechanical advantage is 2 and velocity ratio is also 2 here. In this case, the fixed pulley is used only to change the direction of effort. Let's see the difference between a single fixed pulley and single movable pulley. In single fixed pulley, the pulley is fixed on the rigid support. The mechanical advantage and velocity ratio is 1 in ideal case. The weight of the pulley itself does not affect its mechanical advantage and is used to change the direction of effort from upward to downward. Here, load and effort moves in opposite direction and the axis of rotation does not move in space. In a single movable pulley, the pulley is not fixed to a rigid support. The mechanical advantage and velocity ratio is equal to 2 in ideal case, and in actual practice, the weight of the pulley itself reduces the mechanical advantage. It's a force multiplier. Here, load moves in the direction of effort and the axis of rotation also moves in space. Now let's see the combination of pulleys. The combination of pulleys can be made in two ways. By using one fixed pulley and several movable pulleys attached to the same rigid support, and using several pulleys in two blocks, which is called block and tackle system. Here we are going to learn about the block and tackle system in detail. In a block and tackle system arrangement, two blocks of pulleys are used. Both the blocks contains several pulleys attached on the same frame. The upper block is fixed with a rigid support and the lower block is movable, which is called tackle. The number of pulleys in the lower block is either equal or one less than that of the upper block. The effort is used in downward direction for the convenience of the person who is using it. This is a block and tackle system of 3 pulleys. The upper section is called block, which is fixed with a rigid support, and the lower section is called tackle, which is movable. Block has more number of pulleys than tackle here, because practically we need to add the weight of the movable pulley as effort. So effort will be more than that of the load, which will be equal to load plus weight of the movable pulley. So to reduce the weight of the movable pulley maximum, least number of pulleys are used in tackle. Now let's see the mechanical advantage and velocity ratio of this pulley system. The load exerts a force in downward direction, which is balanced by the reaction force of the strands that supporting the movable block or tackle. Here, 3 strands are supporting this movable block, and the tension of the 3 strands together supports this load. Since we are using the same thread, same tension for all these strands. So here the load is supported by the tension of 3 strands. Hence, load is equal to 3T or 3 times the tension, because the weight of the load is equally distributed to these 3 strands. Hence, load is equal to 3T. Now, we are giving a force here as effort in downward direction, and this effort is balanced by the tension of this free end in upward direction. Hence, effort is equal to T. Now we can see the mechanical advantage in this system is equal to load by effort, that is 3T by T, which is equal to 3. Since mechanical advantage is equal to velocity ratio in ideal case, we can directly write velocity ratio also equal to 3. So here mechanical advantage is 3 and velocity ratio is 3. So in a 3 pulley system, the mechanical advantage and velocity ratio is 3, and this block and tackle system is used as a force multiplier. So dear students, please note the tension of the number of strands supporting the load is balanced with the load. So here we can directly write load is equal to number of strands supporting the load into tension. Effort is equal to the tension of the free end. And mechanical advantage is equal to 3. So we can directly keep it in mind that it is equal to number of strands supporting the lower block. Here 3 strands are supporting the lower block, and hence mechanical advantage is 3. And one more thing, this is having odd number of pulleys, that is 3. But if we are using even number of pulleys, for example 4 pulleys, 2 pulleys will come on block and 2 comes on the tackle. So we uses same number of pulleys in that case. So tackle system consists of either same number of pulleys or 1 pulley less than that of the block system. It is arranged so as to reduce the weight of the movable block. Now let's look the 4 pulley system. Here 4 strands are supporting the load. Hence, load is equal to tension provided by the 4 strands. Hence, load L is equal to 4T. The effort is given on the free end. Hence, effort will be balanced by the reaction force of the strands at the free end. Hence, which is equal to T. So, here load is 40 and effort is T. Hence, mechanical advantage is 4 and also velocity ratio is 4. Same in the case of 5 pulley system. Here, mechanical advantage will be equal to 5 since 5 strands are supporting the load. Dear children, please look. Here all in this case, we are giving effort in downward direction for our convenience. I will give you a tip. In the case of odd number of pulleys, more number of pulleys will be used in block system, and the free end of the string will be connected to the center of the tackle. And in the case of even number of pulleys, we will use same number of pulleys in block system and tackle system, and the free end of the string is connected to the center of the block. So remember this, the free end of the string is connected to the block system in even number of pulleys, and the free end of the string is connected to the tackle system in odd number of pulleys, so that effort is applied in downward direction. Hope you all understood all this pulley system clearly. Thank you and have a nice day.